Alright guys, in these notes we want to talk about how we derive a formula for a parametric function for the second derivative with respect to x. In this situation, remember, we have a parametric function. So, parametric function, and this function is given by f of t, and remember, parametric function just means that we have a function x equals x of t, as well as a function for the y coordinates, y equals y of t. And in the notes, we describe how the derivative from the chain rule, the slope of the tangent line, dy dx, can be computed by taking dy by dt and dividing that by dx, by the derivative dx by dt. And then we have some notation for these two derivatives with respect to a parameter. So this notation only works when you're using it with respect to a parameter, but we can just write this as y dot over x dot. And this is true for any function. So this is for any function that is a parametric functions of y, x and y. So for any function. All right, so in these notes what we want to do is we want to compute the second derivative of y with respect to x. So we want d squared y by dx squared, and the way that we have to think about this is that this is the x derivative of dy by dx, but this dy by dx is, we set up here any function, of course I mean any parametric function. This function is a parametric function of t. It's a ratio of two parametric functions with respect to t, so this is a function of t as well. And so according to this definition, the second derivative has to be the derivative with respect to t of the upper function, which in this case is our dy by dx, divided by dx by dt. So on the bottom that's just another x dot, but on the top we have to compute this. So we have a d by dt of our ratio y dot over x dot divided by another x dot. And of course this function on top has to obey a quotient rule because it's a quotient of functions. So we apply the quotient rule on the top. That's the bottom times the derivative of the top. That's a double dot on the y, second derivative of y with respect to t, minus x double dot times y dot all over x dot, and then again, whoops, x dot squared, low squared, divided by another x dot from this one here. So that's this one. And then if we combine these two fractions, you can think of this over 1, so this just goes there. And so what we end up with is a parametric formula for our second derivative, d squared y by dx squared. This is going to equal x dot times y double dot minus x double dot times y dot all over x dot cubed. And so this is a formula. You can just go straight to this if you want for a second derivative of a parametrized function, a parametric function. And of course, second derivative tells us something about the curvature of the function or the concavity of the function. If we think of it as in terms of, as a usual function in terms of y